Hello, good morning students. Today I would like to discuss about the topic in projectile. The topic is projectile on an inclined plane. Say when an object is thrown from bottom to top and top to bottom on an inclined plane, what happened to the formulas like time of flight, maximum height and range? See, for example, here this is an inclined plane. Here I am drawing the inclined plane here. Say this is an inclined plane. Okay. Now this is the inclined plane here. What is the angle of inclination? Generally, angle of inclination can be considered as theta. Let us, this is the bottom, this is the top. Here is the top one, this is the bottom. Say when an object is thrown from here bottom like this, like this, so in the it will follow the path of the parabolic path. Say on this inclined plane an object is thrown like this, it will follow the path of a parabolic path like this. Let us say at this point of projection the angle will be here alpha. So how can you get the velocity at this point? That means simply by drawing the tangent here. Say here is the tangent, here is the tangent. Now this tangent gives the direction of the initial velocity. Let us say this is the u is the initial velocity. Now this is the angle of inclination, angle of projection. That means you can consider this will be as the x-axis. Now normal to this will be considered as the y-axis. Okay. So in general, as you know that, so now I am for the doing the derivation point of view, here I am changing this frame, that is inclined plane, like this. So say here it will be like this now. Here I am changing the plane to like this, so that will be looking like this. Okay, like this. Now this inclined plane can be considered as the x-axis. As you know, the angle is alpha here. This is the y-axis. This is the projection velocity, that is u. Again, as you know that you can divide the velocity into two components. One is the horizontal component, that is u cos alpha. This is ux. This is uy, which is u sin alpha. Actually, in projectile, as we know that horizontal velocity is a constant, so that horizontal acceleration is 0, whereas in the vertical acceleration will be minus g in case of projectile. So here in case of this inclined plane projectile, here it will have the two accelerations. One is in the horizontal direction, another is the vertical direction. As we know thus, in this case if you observe here, the weight will be acting here is always downward direction. That is, we can say acceleration g will be in the downward direction. Again, if it is a theta, this is the 90. Now this can be 90 minus theta. Okay, this will be 90 minus theta. Proportional angle will be like this. That means this g can be resolved into two components again. One is in this direction, another is in this direction. Now this is 90 minus theta. Okay, that is this will be as usual g cos theta. Now this will be g sin theta. Now you can apply here same thing here at this point, that means we can consider these are the two components. One is negative x-axis, another is negative y-axis. That means this will be g cos theta, there is a minus negative value. This will be g sin theta, this will be negative value. Okay, now got this. In this case, in this inclined plane projectile, it will have two accelerations. One is g cos theta, another is g sin theta. Negative indicates the coordinate system. According to the coordinate, this will be the negative, this will be the negative y-axis. Now, in this case, I am deriving the time of flight for this. Say this is the maximum height h. As you know, this is the range. So look at this. For this derivation, you require the time of flight first. Initially, I am deriving the time of flight for the projectile on an inclined plane. Time of flight. So what is the definition of time of flight? The time which remains the body in the air, that is called the time of flight. If you observe this, in this case, in the y direction, vertical displacement is 0, whereas horizontal displacement will be present. So in this time of flight, only vertical direction will be 0, whereas horizontal will be acting. So for this, I am using the vertical displacement. So in y direction, so what are the quantities, you know? So first of all, from this diagram, I am writing the x and y components like this. On the x-axis, on the y-axis, what are the components we have? So on the x-axis, as you know, velocity ux is equal to u cos alpha. On this y-axis, velocity uy is equal to u sin alpha. What about the accelerations? On the x-axis, acceleration ax is equal to x-axis minus g sin theta. On this y-axis, acceleration ay is equal to minus g cos theta. Whereas in this case, vertical velocity will be 0. This will be used in the next topic. So we better to write here only. That means now we are going to derive the time of flight here by using these formulas. So in this vertical direction, as you know the formula, that is from the equation of motion, s is equal to ut plus half at square. Now I am using this formula for deriving this all. See, look at this. For the y direction, what are the quantities you know in this y direction? You can apply the y direction value also. Sy is equal to uy into time of flight plus half, that is a into ay, you better use ay into t square. Okay. Now substituting the values. As you know that vertical displacement is equal to how much? Vertical displacement in this case is 0. So you can substituting here, you will get 0 is equal to uy, yeah, u sin alpha into t minus, why? Because acceleration ay is equal to minus g cos theta, half g cos theta into t square. Okay. Now t will be cancelled. From this you will get time of flight u sin alpha is equal to 1 by 2 g cos theta into t. From this you will get time of flight t is equal to 2u sin alpha by g cos theta. Yeah, we'll get the formula for the time of flight in case of the projectile on inclined plane from bottom to top. So here I am considering, remember that here I am considering y direction, that is important. So that means, as you know that in case of projectile, so we know that in oblique projectile, you know the formulas for the time of flight, that is a time of flight is equal to 2u sin theta by g. Okay. Whereas for the maximum height, the formula is u square sin square theta by 2g. Whereas for the range, that is u square sin 2 theta by g. Okay, these are the formulas in the oblique projectile. Now from this you can get the formula. You can better to write in terms of axis. Easy point of view. U sin alpha is nothing but uy. That means you can simply write 2uy by g cos theta. G cos theta is nothing but acceleration on the y-axis. That is simply you can write ay. So this is the formula for the time of flight when an object is thrown from bottom to top. This is for the bottom to top. Yeah. So this is the formula for the time of flight. Next will be the maximum height. How can you derive the maximum height? Point number 2, that is maximum height. So maximum height means where the vertical velocity becomes 0. So an object is like going like this, actually velocity will be increasing. At this particular point, maximum height velocity will be 0. That is the horizontal velocity in general. Okay. Now while going to the downward direction, velocity gradually increases. When it is reaching the bottom, the velocity will be the maximum. So by using that, in this case, the vertical displacement, let us say this is the vertical displacement. So what are the values? You know, vertical displacement is s is equal to h. Okay. Some more. What about the vertical formula? Means here we can use the formula, that is the equation of motion, v square minus u square is equal to 2as. That is vy square uy square 2ay sy. All you can is the vertical components. So as you know that the vy square, that is vy square, how much? Vy square only. So vy square how much? That is 0. So there is 0. That implies we can apply here 0 is equal to uy square. That is uy square means how much? Yeah. So you can 0 minus uy square means u square sin square alpha, which is equal to 2 into ay. Ay means what? Minus g cos theta. Keep in the bracket. Into sy. Sy means h as usual. So minus minus gets cancelled. From that you will get maximum height h is equal to u square sin square alpha by 2g cos theta. Or you can write simply h is equal to u sin alpha means uy. Okay. That is simply you can write here uy square by 2ay. That's all. This is the formula for the maximum height in case of the inclined plane. An object is thrown from bottom to top. Next, one of the important topic here is a range. This is very important topic. So that is a range. So in this concept, range means this is the horizontal distance traveled. It is nothing but the direction. Now in both the time of flight and maximum height, I am considering the y-axis, whereas in case of horizontal, that is a range, we have to consider x-axis components. What it? As you know that in the x-axis, ux is equal to u cos alpha, ax is equal to minus g sin theta. So that we have to use here. Now, what are the quantities you know on the x direction? So in this x direction, what do you know? Ux is equal to u cos alpha, gx is equal to minus g sin theta, sx horizontal distance is nothing but range, or time is equal to time of flight, capital T. Now again I am using from equation of motion, that is s is equal to ut plus half ad square. So in the x direction, that means sx is equal to uxt plus 1 by 2 axt square. Now substituting the values, sx, that is r is equal to ux means how much? U cos alpha into time of flight, as we know this is the time of flight. Substituting here 2u sin alpha by g cos theta, keep in bracket, yeah, plus ax means minus g, you better use the minus here, half into ax means what are the value? Ax is equal to how much? This is ax minus g sin theta, so minus already put, g sin theta into t square, this whole square, that is 2u sin alpha by g cos theta whole square. Okay, now simplify this. Now you will get from this, you can take out the common, 2 is the common. Okay, some more I am writing clearly. Here it is 2u square, u better u square sin alpha cos alpha, okay, by g cos theta minus, so 1g cancel, okay, better write some more clearly, sin theta into 2u square sin square alpha by g square cos square theta. So 1g will be gone, 1 will be there. From this, and take out the common as For my convenience, 2u square by g cos square theta. I am directly taking the common. Okay. Now here cos theta means into cos theta by cos theta. Divide and multiply with cos theta in this case. So that you can get g cos square theta as the common. So upside some more sin alpha is there. Sin alpha is also taken as the common. Now what do you have? Yeah, 2 is also coming out, u square is there, that is here cos theta is there. That means cos theta cos alpha minus sin theta sin alpha. So this is in the form of cos A cos B minus sin A sin B in mathematics. The formula for this will be cos A plus B. So you can use the formula cos A plus B is equal to cos A cos B minus sin A sin B. So this is the formula you have to remember. Now in place of this you can better to put R is equal to 2u square sin alpha by g cos square theta into, you can use cos alpha plus theta. That's it. This is the derivation for the range in case of an inclined plane in the projectile part. Okay. Say if you use this topic in the when an object is thrown from top of the projectile to the bottom of the projectile, it is also looking like a parabola. Here in both the cases, bottom to top and top to bottom, here for derivation of the maximum height and time of flight, we use only y-axis. That means in the y-axis, when it is going from bottom to top or top to bottom, there is no change in the direction y-axis. That means in both the cases, from when object thrown from bottom to top or top to bottom, time of flight and maximum height are same. Whereas in case of range, it will be changed. From here to here means range will be changed. So simple thing is here when it is bottom to top means alpha plus theta is there. When it is top to bottom, the value simply changes to alpha minus theta. That's all. Thank you for watching.